In the first part, we dealt with the gyroscopic inertia of rotating bodies. We saw that any rotating body will maintain the direction of its axis of rotation, provided no force acts on it. But what happens when an external force acts on it? In the case of bodies which are not in rotation, the force results in a movement along the direction of the application of the force. But in the case of rotating bodies, the force yields a different result. Here, when I try to push the rotor in this direction, the motion of the frames is along a different direction. When I apply a force here, the motion of the frames is in an entirely different plane. This strange feature is known as precession. Precession is defined as the tendency of a spinning body to move along a perpendicular direction to the direction of the applied force. To learn more about precession and how it affects a body, we'll have to look at some definitions. We know what the axis of rotation is. The direction of the axis of rotation is defined as the longitudinal direction in which a rotating right-handed screw would move. A torque is a force that causes a body to turn. The direction of the torque is the longitudinal direction in which a right-handed screw would move when the torque is applied. When torque acts on a spinning body, the direction of the axis of spin turns towards the direction of the torque. This is a phenomenon of precession. Here, when the rotor is rotating in this manner, its axis is pointed in this direction. Force is applied from above to produce a turning effect, and so the direction of the torque is along the horizontal. Now, due to precession, the axis of rotation turns towards the direction of the torque. So, a spinning gyroscope will move at right angles to any force that attempts to change the direction of its axis. The phenomenon of precession can be seen in the case of a rolling hoop. To turn the hoop, pressure is not applied to the front or rear of the hoop but against the top. The hoop does not fall over but turns a corner due to precession and proceeds in a new direction. Precession is a phenomenon that we see every day. A rolling coin remains vertical because of its gyroscopic inertia. As it slows down, the coin moves out of its vertical position and the gravity begins to pull it down. Due to precession, instead of falling straight, it begins to turn and then flaps down. The principle of precession can be seen on a bicycle wheel supported on both ends of the axle. When one of the supports is removed, the wheel tilts because of the force of gravity acting on it. When the wheel is rotating, precession comes into play. When I remove one of the supports, the wheel continues to rotate, it does not tilt, and at the same time, it moves around an axis. All these motions are in play in the spinning top too. While it is spinning on its vertical axis, there is no torque and gyroscopic inertia keeps the axis vertical for a long time. As it slows down, the top begins to tilt. Once the top tilts, the gravity produces a horizontal torque that leads to the precession of the spin axis. This causes the top to wobble around. Now let's come back to the case of a bicycle and see how precession helps in maintaining the balance. Like gyroscopic inertia, precession also contributes to a bicycle's stability and steering ease. The rider usually maintains a vertical position. When he wants to turn right, he leans on to the right side. The leaning produces precession in the wheel and makes turning easier. Like in the case of a rolling coin, it is the precession that helps turn the bicycle. So the next time you mount on a bicycle, keep this in mind. It is the same force that keeps the satellites in their position that helps you balance yourselves in the bicycle. What the sailors and the pilots make use of is the same peculiarity of the simple spinning top. So ponder a bit more seriously over such simple things. There could be great scientific principles behind them.